Now, before we begin, I wanted to talk a little about inflammation. I and most of us tend to think of inflammation in terms of sore muscles and aching joints. We typically take an ibuprofen, which reduces inflammation, and the pain goes away, but it's not that simple. Chill or Julius, from what I now understand, we can also get inflammation from the foods we eat, such as processed foods, refined sugars, refined carbohydrates, trans fats like margarine, and even alcohol. Can you please explain how the foods we eat can cause inflammation?
Right, the foods we eat can actually cause inflammation. But first of all, we have to understand that inflammation is a normal body function and forms part of the immune system's response to a stimulus. And what you just described about sore muscles is one of two main types of inflammation, which is the acute inflammation. The other type of inflammation, chronic inflammation or low-grade inflammation, is more generalized and occurs throughout the body and is generally accompanied by a rise in immune markers like cytokines. Sugars are the major culprit in releasing cytokines that cause inflammation. We should understand that sugar is a general term and includes fructose, glucose, sucrose, lactose, and maltose, things that are generally seen on the labels of foods. Foods high in trans fats include specialties of fast food restaurants like French fries, packaged cakes, and cookies. Also, processed meats, which have high levels of advanced glycation end products, are known to cause inflammation.
So how exactly does this inflammation cause metabolic hormones to become unbalanced, and how exactly does that lead to weight gain and also problems with losing weight?
Well, when we talk about weight gain or weight loss, the focus is generally on the adipose tissue, which for a long time was considered an inert organ, mainly to store excess body fat. We, however, now know that the adipose tissue is a metabolically dynamic endocrine organ and an important source of several hormones, cytokines, and complement proteins involved in many metabolic pathways, including inflammation and insulin sensitivity. A key substance released by the adipose tissue is leptin, which regulates food intake, energy expenditure, and the inflammatory response. Leptin is therefore central, as its role is to tell the brain to stop eating. Excess secretion of leptin could lead to leptin resistance, where the hypothalamic cells of the brain stop recognizing leptin signal, causing the brain to turn on the hunger signal and consequently continue eating.
How do ingredients affect inflammation and ultimately help the metabolic hormones become rebalanced?
The different ingredients in tetragen directly or indirectly affect inflammation. Evingia gabonensis downregulates leptin production and can significantly reduce leptin resistance and consequently weight. CQR300 from Cissus quadrangularis decreases the levels of CRP in overweight people, consequently reducing inflammation, while diglomera is a powerful antioxidant which is very important in controlling the inflammatory process. These ingredients put together would effectively reduce weight, the inflammatory process, bringing down the body's metabolism back to normal.
Okay, so in some cases, intake anywhere from 2 to 6 weeks from ketogen to work. Does that mean that some people have higher levels of inflammation, which is why it can take longer for some to see the effects?
Right. Everybody is different, and this is a genetic fact. What that means is that our bodies react differently to different stimuli, including those meant to reduce inflammation. Experience over the years working with these ingredients confirms the mechanisms of actions for them, as well as the fact that these mechanisms of action will kick into play differently for different people.
I'd like to finish up by talking a little more about inflammation itself. What are the long and short-term health consequences of chronic inflammation?
Long-term chronic inflammation is really something to be avoided. As we mentioned initially, and unlike acute inflammation, which is localized, chronic inflammation is generalized and plays a role in the development of many diseases. Inflammatory cells in circulation can form plaques, which ultimately become clots that can block blood vessels, triggering a heart attack or stroke. Prolonged chronic inflammation can lead to DNA damage, tissue death, or internal scarring. This could lead to the development of several diseases, including cancer, heart disease, rheumatoid arthritis, type 2 diabetes, obesity, and many others.